Alright, let's get to it. Example number 1. Here is the graph that you're looking at. Here's what I want you to write down though. This is the general form of an absolute value function. Okay, write that form down because A will represent something, H and K, all these things mean something. Okay, this can be a tricky section if you don't remember all these little things. Okay, so make sure you take good notes here. Now look at this equation right here. This has absolute value, which means it's going to produce a V. Okay, now where that V is actually somewhere else. So let's actually use our calculators right now. Absolute value of x plus 4 minus 2. I'm just going to show you a couple things. Okay, turn it on. Y equals absolute value. Now where do you get absolute value? Go to the math key right here and go to, let's see, NUM right there under num ABS. That means absolute value. Hit that. Absolute value of, I forget, x plus 4, I think it was. X plus 4 and then minus 2. So x plus 4 and absolute value. That's all those in absolute value. And then you have a plus 2, right? Nope, minus 2, sorry. Minus 2. Alright, let's graph this. Look at it. It's still a V, right? Still a V. What about the parent? If you were to graph the parent would be right here. Actually, let's do that. On graph number 2, we'll graph the parent. Math, absolute value of just x. See that? That's the parent, absolute value of x. Graph both of them because we're going to compare. See the parent right here in the middle? How does the parent compare with the other one right here? Okay. Do you think it got wider or did it change the shape at all? It didn't, right? All it did was it shifted. It shifted. If you look here, it started here, you went left a couple and then down a couple. How many? Do you have to guess? No, it's all right here. It's all right here. Look at this. This and this. Now look at this. This is the tricky part. It's supposed to be x minus h. So how could I rewrite this? X minus negative 4. That's the same thing as x plus 4, right? Same thing. And then a minus 2 out here. If I did this, look what happens. H, what is H? Because H comma K, write this down, is your new vertex. H comma K, right? Star that. What is H in this case? H is actually negative 4, right? You see that? X minus H. X minus H is negative 4, not 4. So negative 4 is H, comma, plus K. So I could change minus 2 to plus a negative 2. So really you're taking whatever this is, so negative 2. This is what tricks people the most. People think, ooh, H is, that's a positive 4, so positive 4. No, it's supposed to be X minus H, so X minus negative 4, so H is negative 4. Put that in for H, comma, K. Alright, please don't mess that up. That's the most common mistake. Alright, I just circled your vertex. So you plot that vertex on a graph. Negative 1, 2, 3, 4, comma, negative 2, and there's your new vertex, which that's what you saw on the other graph. And then you're going to see the two lines going this way to make your V. Okay? So I'm just going to draw a rough sketch. That's a rough sketch. But you can see it's right here. Okay, negative 4, negative 2 is that vertex right there. Now how does this compare? All it did was translate left how many? Left 4 and down 2. That's what you have to write down on here. So when it says compare, you're going to say it translated left 4 and down 2. How do you get these two things? Right here. Negative 2 means down 2. That's supposed to be minus a negative 4. So negative 4 means that's why it's left. Left 4, down 2. All based on just looking at negatives and positive signs. Okay? That's the comparison. That's part of it. Anyway. Okay? A fool, let's see what they write fully here. compare with this. So here's their final answer, I believe. The graph of this compared with the parent is translated, have to use that word, down 2 and left 4. Okay? That's the main idea in this particular graph. Okay? Notice the two vertices here and here. Comparison. That's it for example